So when we're talking about certain parts of the brain or certain brain regions, we're looking at, the cerebral cortex and the hippocampus, for example, are more involved in explicit memory. And remember, we said explicit memory is like your semantic and your episodic memory.
Nanime?
Who's that?
Zoya.
Zoya means so.
Semantic and episodic. Okay, so that's semantic and episodic memory. Okay, and the amygdala and cerebellum play more of a role in your implicit memory. So specifically, cerebellum is to do with movements, and usually in procedural memories like riding a bicycle, blah, 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 we generally tend to engage in movement, right? So we say cerebellum plays a big role in procedural memory, and the amygdala doesn't really play a big role in procedural memory as much as the cerebellum, but plays more of a role in memories that are associated with things like fear or anxiety and that kind of stuff. So we say that amygdala plays a role in a specific type of implicit memory called classically conditioned memory. So remember when, for example, little Albert got scared of the white rats and he learned or was conditioned to develop a fear of white rats, he was able to do that because his amygdala was still intact. He was able to remember in his memory the association between the white rat and the fear that he experienced. Okay, and remember, he didn't naturally fear white rats, because remember that video we watched, he was playing around with the white rats. He liked the white rat in the beginning, but as he learned to associate the fear with the sight of the white rat, that's when he would start to, become scared in the future. Every time he saw the white rat, he would run away, he would cry. So that shows you the implicit classically conditioned memories are the responsibility of the amygdala. Okay. So, and I'll go back to that long-term memory breakdown to just show you to show you the different types. Okay, let me just go back. One more. Okay, so when we look at our diagram from this slide, let me just remove all the scribble. See, long-term memory is divided into explicit memory. Explicit memory is divided into semantic and episodic. And with implicit memory is involved in two types: procedural, which is the one we mostly go through, but that doesn't mean that you will never be asked about classically conditioned memory. Okay, that's the memory of an organism to remember the association between one stimulus and another stimulus. So for example, little Albert's ability to remember the association between the white rat and the fear that he experienced is because of his implicit memory. Okay, the memory of the association. In other words, Pavlov's dog's ability to remember the association between the ringing of the bell and the presentation of food was again an example of the implicit memory. Okay, some questions. What does the amygdala control? The amygdala controls or is responsible for embedding or attaching emotional components to our memories. So for example, if I have an episodic memory of a time that I was walking home from university and it was getting dark and someone was like following me, I would have obviously become very nervous and very scared, okay, and very agitated. And because of that, the amygdala would have attached the emotion of fear or the emotion of feeling upset or feeling anxious to that memory. So every time I think about that memory of that day I walked home from university, I would remember how scared I was. So that fear gets embedded very strongly into that memory. Implicit memories, depending on the type of implicit memory we're talking about, procedural implicit memories are stored in your cerebellum. I'll talk a little bit more about this. And classically conditioned memories basically tend to be involved or stored in the amygdala. Okay, so this role of the brain region is for classically conditioned memory, and cerebellum is for procedural memory. Okay. What does the amygdala control? Okay, what other questions have I missed? What's the subcortical region? Subcortical region is not really something that we need to know. You need to know that the word cortical means relating. Oh my God, let me put my phone on vibrate. When we're talking about the subcortical region, cortical means brain. You need to be able to know that. But in terms of the subcortical region, it's not really something we need to know. It basically just refers to a part of the brain. So basically, when we look deep into the brain, we've got different structures that are responsible for the release of hormones, like the pituitary gland and all that stuff. But we don't actually go through, we don't actually do that in our study design. So if you've seen that somewhere, it shouldn't have been there. That won't be examinable content. Okay, so don't worry about subcortical region there. What kind of questions would we be asked if we had to talk about the regions? Okay, I'll see if I can find a question that represents this content. Can we see questions best? Yes, I will see that. How about the cerebral cortex? Is the amygdala involved in both implicit and explicit memories? Okay, the amygdala is involved mainly in implicit memories. It's not, we have to be careful with the way we word the answer. Okay, so if I talk about the amygdala, for example, the amygdala is involved mainly with attaching emotions to memories. Okay, so I can actually, the amygdala is involved in, for example, attaching emotion of fear to an episodic memory, but it's not involved in the actual formation or storage of the episodic memory itself. So that memory as a whole is the responsibility of firstly the hippocampus, which consolidates it, and then that episodic memory is stored in the cerebral cortex. Okay, remember, episodic memory and amygdala have like no connection, only except for the fact that the amygdala embeds or attaches or puts on the emotional component to that memory. But other than that, the amygdala is not involved in the storage. It's not involved in the consolidation or the encoding of the actual episodic memory. It's just involved in embedding or attaching the emotional components to that memory. So just be careful there, okay? This is why I wanted to show you guys that memory tip, because that memory tip clearly identifies each one. Yep, we'll look at those multiple choice questions as well. The cerebral cortex. Okay, let me just go through the rest of the content here. So the cerebral cortex has a main role in episodic and semantic memories or explicit memories. So remember that when we store an episodic or semantic memory, first of all, that information is consolidated or strongly fixed into our memory through the hippocampus. Consolidated by the hippocampus. But in terms of the storage, it's stored in the cerebral cortex, okay? So the encoding or the consolidation happens in the hippocampus for episodic and semantic memories, but the actual storage site is in the cerebral cortex, okay? Generally what that means is that most of our episodic memories tend to be stored in the frontal lobes and the temporal lobes, okay? That's the basic idea. Mostly though in the frontal lobe. So the temporal lobe does more of that consolidation because the hippocampus is inside that temporal lobe. Okay, so consolidation or encoding happens here, consolidation / encoding, and the storage happens in the frontal lobe or the prefrontal cortex. Okay, however, when it comes to the different components of those memories, for example, the sound of a particular song that you heard when you went to someone's party, all of that is stored throughout the entire cerebral cortex. So because sounds are responsible, the role of the temporal lobe, okay, sound related information, the sounds of a memory are often stored in the temporal lobe. The visual images of a memory are stored in the occipital lobe. When you recall the information of a night or somewhere you went, all of these lobes kind of integrate that information to allow you to then recall that again, okay? But yeah, in simple words, encoding of explicit episodic and semantic memories, encoding / consolidation, they're sometimes called the two different things. Encoding / consolidation of episodic and semantic memories, which are our explicit memories, happens in the temporal lobe due to the presence of the hippocampus in the temporal lobe. And the actual storage site for these episodic and semantic memories. So for example, your memory of lockdown last year, your memory of the last day of school before we went back to remote learning, all of those memories are stored in your frontal lobe, specifically in that prefrontal cortex. Okay, so just make sure you are able to differentiate between encoding, which is the initial processing of a memory, and storage. Okay, storage is where that memory ends up getting stored or retained, and encoding is the initial processing or consolidation of that memory. So that's the kind of two differences there. So in short, consolidation. Yes, that's exactly correct. Does a person still have a good procedural memory if they have Alzheimer's disease? No. If you have Alzheimer's disease, your cerebellum is not affected. but your hippocampus is affected. So for example, someone with Alzheimer's disease, their hippocampus, the neurons in the hippocampus start to get destroyed little by little. It's a neurodegenerative disease. So slowly or little by little, you've got a destruction of the neurons in the hippocampus. What that means is, obviously, in order for us to store a memory to reach here, it needs to be consolidated first, correct? If our hippocampus, if you've got Alzheimer's disease and your hippocampus is slowly deteriorating and slowly degenerating in terms of its function, the memories are not going to be consolidated well. If the memory is not consolidated or encoded well in the hippocampus to begin with, how can it get stored? Okay, and this is why people who have Alzheimer's often experience anterograde amnesia. They can't form new memories. They can only remember what happened ages ago before the injury or before the damage, but they can't form new memories. They can't learn new things. Why? In order for you to learn something new, you need to be able to consolidate that information. Only then can that information be stored. If consolidation can't happen in the hippocampus, neither can the storage of that information either. Okay, that's the general kind of relationship between the two. Okay, so generally, to answer your question, the question is, does a person still have good procedural memory if they have Alzheimer's disease? The answer is yes. For the most part, a person who has Alzheimer's disease, if they enjoyed playing golf, they can still play golf. If they enjoyed cooking, they can still cook their favorite meals. Okay, so that's the basic idea. But I'll just give you an example. So if someone with Alzheimer's disease, before they got the Alzheimer's disease, if they loved cooking and they could cook all these meals, they didn't even need recipe books, they just knew it like the back of their hand, they can still do those recipes that they already know. They can still cook their family a nice dinner. But if it comes to learning a new recipe, or like, for example, if it comes to learning a new method of cooking from a textbook or something like that, or from a video, they might not be able to learn that, okay? Because instructions or those kinds of information are more to do with semantic memories. And we know that people with Alzheimer's who have anterograde amnesia most of the time can't form new semantic memories, okay? So that's the basic idea. Let's see, what else? What other questions have I missed? But your amygdala does store emotional memory. Yeah, so when we say emotional memory, we're talking about emotional components of memories. So the amygdala basically is involved in the emotional components of episodic memories and implicit memories. What do we mean by emotional components? One type of explicit memory to which amygdala attaches emotion is episodic memories. So for example, remembering how scared you were when you went on your first roller coaster at Luna Park, okay? That's an episodic memory. The amygdala was involved in attaching the emotion of fear to that memory. The overall memory of everything you did, how your dad bought your ice cream afterwards, all that stuff, that's not the role of the amygdala. That's the role of the kind of a cerebral cortex there, okay? That memory is now stored in your cerebral cortex and was initially consolidated by your hippocampus. So that's the difference. The amygdala is only to do with the emotional component, not the whole memory as a whole, okay? Just the emotion. And the same thing for the amygdala also attaches emotional components to classically conditioned memory. So we've done so many scenarios of classical conditioning where a person gets chased by a clown down the street and, oh, okay, now they've got a phobia of clowns. So there's an emotional component there because now every time the person sees a clown, they remember the emotional association they made of clowns and fear, okay? That ability to remember that association and remember that fear is because the amygdala was involved in attaching the fear to that classically conditioned memory. So these are the only two instances in which the amygdala plays a role in terms of memory, only in terms of attaching emotions to memory. Okay, what other questions do we have? Let's have a look. How about the parietal lobe? No, the parietal lobe doesn't play a role in memory. It's there, but it doesn't play any major role in memory there. It kind of does, like parietal lobe could be involved in things like your memory of textures, but we don't go into it in that much depth. So if you really want to know, like, for example, if you go to a store and you remember like feeling a specific texture of material for your graduation dress, and you go into a store and you're like, this is the exact material I want. When you feel that material in another store, and your brain's ability to remember that, oh, this is exactly like the material I was looking for, or this is too thick, or this is too silky. The ability to remember those textures is a function of the parietal lobe, but not very relevant to long-term memory in terms of how we study it. Okay. So if a question asks for a question, I would have to look for, yes. So if a question asks for a question on this topic, you would have to look for whether it says consolidation. Well, not consolidation. Sometimes the questions don't say consolidation, they say encoding or formation. So if your question is asking you, I'll just write this down. And honestly, this is kind of VCAR's fault as well for using so many different terminologies, but encoding, formation, consolidation are basically the same thing, or kind of all kind of end up in the same result. These are to do with before the memory is stored. It's kind of the processing level, if you want to call it that. Okay. And what was I going to say? Storage and retrieval are after the memory. Obviously, after the memory is stored, you can only retrieve a memory afterwards. So this is like after the processing, after the initial processing level. So depending on what your question asks you, whether it asks you about the encoding of a memory that a person has gone through, whether it's asking you about how that person will then retrieve that information or where that information is stored, you will be referring to possibly a different area of the brain regions in this particular topic or from this particular topic. Okay, so you just need to look at and differentiate between that. Miss, the 3 hallmark feature is for Alzheimer's. Yes, the 3 hallmark features are amyloid plaques, neurofibrillary tangles, and abnormally low levels of acetylcholine. They are all associated with Alzheimer's disease. That's correct. So the temporal lobe is where info is encoded, and the frontal lobe is where info is stored. Exactly. Yes, spot on. That's exactly what it is about. Isn't doing something procedural though? Yes, doing something is procedural, but I don't understand the context of that question. I think I read it too late. But yeah, clarify that question for me and then I can explain it a bit further. Okay, so that's the cerebral cortex. So just in very, very brief summary, temporal lobes involved in the encoding, the formation, the consolidation, whatever you want to call it, of explicit memories, whether that's an episodic memory, whether that's a semantic memory. And those memories are then stored in the frontal lobe of the brain. Okay, that's the basic idea. Guys, in an exam question, they don't always refer to the lobes. They might just refer to it as the cerebral cortex. So you might get a very vague or generally worded question like outline, let's say a scenario, and then something like outline the role of Aisha's cerebral cortex in the in the encoding, storage, and retrieval of the memory of her year 12 graduation. So this is an example of a question, and it could be worth something like 3 marks. This is an example of a question that is possible in terms of this kind of a topic. Okay, so you can see here it says outline the role of Aisha's cerebral cortex in the encoding, storage, and retrieval. So now that we know, guys, how would we attempt this question? Or give me like a few points that you would include. There are 3 main parts to this question. So we need to talk about how the memory of her year 12 graduation was encoded, how it was stored, and how it was retrieved in terms of the cerebral cortex, so the specific areas. So how would you break this question down? Remembering it's worth 3 marks, and there are 3 kind of things you need to make reference to. Yep, so it's encoded by the hippocampus, correct? It's encoded and consolidated by the hippocampus, which is in our temporal lobe. That's correct. So that's what we would talk about for the encoding side of things. And then where would it be stored? Yep, it would be stored in the frontal lobe, correct? And then when it's retrieved, obviously storage and retrieval go hand in hand. So when it's retrieved, it would also be retrieved from the frontal lobe and would come into Aisha's conscious awareness. So she's consciously thinking about it now. Because remember, we said that usually whatever's in your long-term memory is not in your conscious awareness until you think about it and you bring it back into your short-term memory or back into your conscious awareness. Okay, so that's how we would approach a question like that. Literally just talking about encoding, which is where it was initially processed, where it was then stored, and then where it was retrieved. And it's always retrieved from the same place where it was stored, right? So that's the basic idea. If they ask you a question like outline the role of her cerebral cortex, I would say it's better to make specific reference to the lobes of the brain. If they just say, let me just cross out cerebral cortex here. And if they say something like outline the role of Aisha's brain regions in the encoding, storage, and retrieval, you don't have to mention the lobes, but I think it makes for a clearer and more specific answer and a better answer if you include the lobes anyway. Okay, but if worse comes to worse and you can't remember the names of the lobes, just talk about the cerebral cortex in general and you'll still get some marks there. Okay, alrighty. So that's for explicit memory. That's mainly for your episodic and semantic memories. Okay, when we're looking at implicit memory, so I'll just move on to, so again, this is the hippocampus. Consolidation. So remember, consolidation and encoding, they are basically the same thing, but I don't know why your textbook said they're not. But for the purposes of the exam, you can think of them as the same thing. Okay, so that's the basic idea. What else can we talk about here? Yeah, not involved in the formation and retrieval of implicit memories. Yeah, look, this topic is really I guess you could say not controversial, but it's always a bit of a headache because different books say different things and VCAR tells us a different thing, and it's yeah. But I'll try to, you know what I'll do? I'll make a clear table for this topic and then I will put that on Schoolbox. I'll also find that memory tip because I know this topic is a bit confusing. And then you guys can have a clear idea of which part of the brain is involved in encoding, which part of the brain is involved in the storage and retrieval. Okay, so I'll put that up after today's lesson. Yes, if you've got a SAC after this, you can go and study for it. That's fine. Just relearn the record, just re-listen to the recording. Okay, amygdala. So the amygdala is involved, like I said before, in the emotional components of memories. I'd kind of crossed this point out. I mean, like it's involved in procedural memory, but not to the extent that cerebellum is. The cerebellum is more involved in the formation of procedural memories there. I would say the amygdala plays a bigger role in terms of your classically conditioned memory and that associative learning. Okay, so being able to make the association between seeing a white rat and feeling fear. Okay, the fear is the emotion and the white rat is the stimulus there, the neutral stimulus, which then becomes a conditioned stimulus. So remember, the amygdala is involved in embedding emotions or encoding emotions into memories, particularly explicit memories, but also implicit memories with reference to classically conditioned memories. Okay, that's the main idea. Okay, and then if we go to the last one, which is the cerebellum is involved in motor learning. It plays a specific role in your implicit memory, specifically the type of implicit memory, which is known as procedural memories. Okay, and this is because the cerebellum is actually involved in motor functions, in movements and things like that. So your ability to ride a bike, for example, is dependent on your motor coordination and on those kinds of motor skills, your ability to swing a tennis racket. And it's not just sports, even your ability to drive a car, your ability to bake a cake. All of these things involve motor skills. Some of them are more complex motor skills, some of them are more basic, but still a motor skill is a motor skill, and those motor skills are the responsibility of the cerebellum. That's why the cerebellum has a role in procedural memories, because most procedural memories involve some kind of skilled sequence of movements. Okay, and so that's the reason why the cerebellum is involved in the formation, the encoding, storage, and retrieval of procedural memories. It plays a very, very big role in procedural memories there. Okay, so does that make sense, everyone? Is that, a few people had this question, had a question, had some doubts about this topic. So I know it's a bit confusing and there's a lot of conflicting information as well. So I'll try to, like I said, I'll make the table and I'll put it up on Schoolbox, and then you can have a bit more clarity there. In regards to implicit memories, does the hippocampus consolidate the emotion and the cerebellum store the memory? With reference to implicit memories, no. So with reference to implicit memories, the amygdala, so whenever you think about emotion, it's always amygdala. Okay, so the amygdala is the one that encodes that emotion, and depending on what type of memory we're talking about, if it's a classically conditioned memory, that is the responsibility of the amygdala. Okay, and that is, the cerebellum doesn't really have a role there. Only with reference to implicit procedural memories does the cerebellum come into play. Okay, but with reference to classically conditioned memories, it's the amygdala that actually encodes or consolidates that emotion into that memory. Yeah, whenever, regardless of whether it's implicit or explicit, amygdala always is the one that encodes or attaches the emotional component to the memory. So whether that's a classically conditioned implicit memory or whether that's an episodic explicit memory there. And the hippocampus just plays a kind of general role in the consolidation of memories. Okay, explicit memories there. Remember, guys, when we did, I think this topic is confusing because when we do the consolidation of emotionally arousing experiences, we say that the hippocampus consolidates the final memory, strengthens it into long-term memory. But we have to remember that that sentence is actually referring to the whole memory, that the hippocampus consolidates the whole memory. If you guys remember the steps involved in that process, yes, the hippocampus is in the temporal lobe. If we remember the steps involved in that process, remember we said whenever we go through a fearful experience or a stressful experience, we said adrenaline is released, and the adrenaline leads to the release of noradrenaline in the amygdala. Okay, key word here being amygdala. So the amygdala comes into the picture even before the hippocampus does. And then we said the amygdala then sends a signal to the hippocampus to then consolidate this experience into long-term memory. So this was the general pattern with reference to, oh my God, what color did I use? Anyway, this is the general pattern with reference to the consolidation of emotionally arousing experiences. Noticing here that the amygdala comes before the hippocampus. So by the time the amygdala sends the signal to the hippocampus to consolidate, the amygdala has already embedded the emotional component that, okay, this person showed fear. The amygdala is like, okay, I'm embedding or I'm encoding the fear into the memory or into the experience before the hippocampus consolidates that experience. Okay, so the amygdala has already done the emotional encoding of the memory even before it sends the signal to the hippocampus. And then the hippocampus does the final consolidation of the whole memory, of everything in that memory, not just the emotional component, but the whole memory as a whole, as a combined thing. I hope that kind of clarifies that confusion there. Yeah. Okay, any other questions, guys, with reference to brain regions involved in memory? No, all good. All right, cool. What's the next topic? What do we think the next topic should be, guys? Just let me know. Which region releases the adrenaline? We don't study specifically about the region that releases adrenaline. It's not really a region, it's actually the adrenal glands in the body. But that's outside of the knowledge that we need to know. So you don't need to worry about, you won't be asked to identify what part of the brain releases the adrenaline. You just need to be able to say that whenever we go through stress, as a natural function of the sympathetic nervous system, we release adrenaline. Yes, of course, you need to know the brain regions involved in memory. It is a study design key knowledge dot point. No, not of any other brain region. You only need to know the 4 that are in this PowerPoint. So cerebellum, amygdala, hippocampus, and cerebral cortex. Those are the only ones in the study design.
Well, the only the brain regions involved in memory. Is that the only part where it's mentioned, like the brain regions?
Which brain regions are you referring to? You mean the ones on this PowerPoint?
Yeah, are we gonna how for our exam we only need to know the brain regions involved in memories? Is there any other brain regions involved in another concept, for example?
Well, we have covered not really regions, but we have covered like names of neurotransmitters and that kind of stuff. But those are in across the board, like in different topics. In terms of actual brain structures or regions, I'd say this is probably one of the main topics where we cover it. Yeah, but just double check with your study design as well, because there are other parts of the unit 3 and 4 where we cover neurotransmitters and not so much brain regions, but other brain related topics. So yeah. Okay, so okay, let's move on to the next topic then. So what do we think? Circadian and ultradian rhythm and how it affects someone's sleep-wake cycle. Yes, we'll cover that. And then scenario questions, which place gets activated first? The spinal cord or the brain? Oh, yeah. So when it comes to, I'll open that PowerPoint as well, so we're not stuck on this one slide for the whole time. Just give me a sec. Let me open up the new PowerPoint. So we need circadian, ultradian rhythm. That's chapter 9. And then we need unconscious and conscious responses. That's chapter 2.
The student in chapter 1, how they say for potential confounding variables as sources of error.
Yep.
Do we need to know the bigger picture, as in sources of error, or it's not really important to know the keyword sources of error, but understand for example,
sources of error is just another word for extraneous or potential confounding variables. So you don't need to know the word sources of error. That's just how Ed Roller has named that chapter. But you do need to know potential confounding variables. You do need to know what's meant by an extraneous variable. So those are important. Unit 3, psychology. Give me 1 second, chapter 2. Where is that PowerPoint gone? Where's this? And I found it. Okay. Okay, so with reference to scenario-based questions and which part of the brain gets activated first, we're really looking at our conscious and unconscious responses. So if it's a conscious response, then we have to think about what the person is doing, and we have to remember that the brain is the one that sends the message first. So the brain is kind of at the forefront. If it's an unconscious response, we have to remember that in order to protect us and in order to enable our survival, it's actually the spinal cord that takes a precedent there, or that takes the preference and goes ahead. For example, in the spinal reflex, remember we said if we're stepping on something that's sharp, or we're holding a really, we accidentally try to get a baking pan out of the oven without oven gloves, it's going to be super, super hot or super, super sharp. Something that's basically really dangerous for us that we need to get away from straight away. So that's basically the threat or the harmful stimulus. The spinal reflex is kind of this evolutionary or adaptive mechanism that is an example of an unconscious response, because our brain is not at the forefront of it. Our brain is not required straight away in order for us to move away from that thing, because the actual reflex, the motor reflex, is initiated by the spinal cord. That's why it's called a spinal reflex, because the spine or the spinal cord is kind of the one that initiates that, okay? In a normal situation, however, for example, if you are sitting next to a heater and it's getting really warm and you feel like your legs are starting to get too hot, and it's starting to become a little bit uncomfortable, you deciding to turn off the heater or you moving your legs away from the heater is a conscious response. It's not something that threatened your survival or was out to harm you. It was just getting a little bit uncomfortable, a little bit annoying, so you just moved your feet away. And that was done with you being aware of that. You made that decision to move your feet away from the heater. It was voluntary. It was goal directed. Your goal was to achieve a more comfortable temperature, okay, because your feet were getting too warm. It was starting to get a bit stuffy. All right. And that's in your conscious control, because conscious responses are always initiated by the brain. So your brain, for example, sends out that motor message through the motor neuron to your legs to move your legs away from the heater, maybe in the other direction, far away from the heater, so they can cool down a little. Spinal reflex is an unconscious response because our brain doesn't have to send out the motor message. The motor message is initiated through the interneurons in the spinal cord, which automatically cause you to move your leg first away from the pin, or move your hands away from the hot baking pan first, and then your brain kicks in later. And it's when your brain kicks in that you feel the pain. Remember, we said brain and pain, they rhyme. So that's basically how that works with the spinal reflex, okay? Your brain kicks in later, and when the brain is activated, the pain is activated for the spinal reflex, okay? The spinal cord takes precedence. The spinal cord occurs first. Remember, when you see the word spinal reflex, it's got the word spinal in it. So that should give you a clue that the spinal cord is the one that initiates the movement, and that in order to feel the pain later on, our brain only activates later on, after the movement has occurred, after we are out of harm's way. Okay. Okay, let me see some questions. Yes, I will go through neurotransmitters and lock and key. And then I will go through, okay, can it be a conscious response if you're in the shower and all of a sudden hot water gushes from the shower thing and you move away? It depends on the scenario. So if the hot water was like really burning hot and it touched your skin and it really hurt you, and you move away really like reflexively or automatically or quickly, then that would be an example of a reflex response. If it's like the water is starting to get warm, but the person's kind of deciding whether they want to move and they're taking a while and they're thinking about it, that would then be a conscious response. So it depends on the urgency of the scenario. If it looks like the person is moving in a very urgent way and it's very critical, it would be unconscious. If they're thinking about it, they're deliberating on it, they're considering it, it's more likely to be conscious. Okay, the more you think about something, the more likely it's gonna be a conscious response. When are sensory neurons involved, unconscious or conscious? Sensory neurons are involved in both parts. So whether you have an unconscious response or a conscious response, sensory neurons are involved. In an unconscious response, when you touch the hot pan, that immediate sensory information is sent in a very fast way to the spinal cord, and then the spinal cord initiates the movement. In a conscious response, if I'm holding a cup of coffee that's quite warm and I want to put it down, that's a conscious response because the sensory receptors in my fingers or my hand have detected the warmth of the coffee cup. Okay, but it's not burnt me, it's just allowed me to think about, okay, I'm going to put this down, wait for it to cool down a little. So sensory neurons are always involved in both conscious and unconscious responses. Okay, yes, we'll look at those exam questions as well. So what I'll do is I will open them up. I just need to go up and check which ones they were. VCAR 2019, question 13, and Psych Ed. Could you just specify the year for the Psych Ed question 7? Because we've got multiple year Psych Ed questions. So just let me know which year exam that was from. I can open up VCAR 2019 in the meantime. Let me just open that up. VCAR 2019. Oh, the Psych Ed, that should be the 2021 Unit 3 Psych Ed. Okay, yep. Let me just open up this first. Also, there's a question with reference to VCAR student number. You know, when you guys went to do your GAT, you might have gotten a little, or even on your exam timetable that you got for your Unit 3 and 4 subject, the one the school gave and printed out for you most likely, there should be a little thing at the top that says VCAR student number on it. It's just a bunch of numbers and then it's got a capital letter at the end, I think. Just look for that. It should be there because you'll need that to access that online exam portal that I linked up earlier today. And you'll need to, anyway, when you do your VCAR exams, you'll need to write that number usually on the front cover of your exam, I think. Okay, let me just open this up. So it was question 13. Just give me 1 second. Okay, and this one is in the drive. Okay, where is it? 2020. Okay, let me just share my screen. I don't know, I have so many screens open, it's not organized. Okay, let's see this one first. So this is the Unit 3. So was it question? Okay, let me go back and check which question it was. Question 7. Yep. Okay, let's go down. Okay, so Tammy was taking notes for her friend who was away from class. When Tammy writes, neural messages are transmitted from her brain to the muscles in her hand. Which of the following correctly lists the type of messages involved? So electrical messages between electrical messages within neurons as well as chemical messages between neurons. Yep, so the answer is C. The reason the answer is C is because when we're talking about, where's my annotating thing? When we're talking about within neurons, okay, when we're talking about within neurons, remember we say within the neuron, as we're going through a single neuron from the dendrite to the axon terminal, does anyone remember the nature of that neural impulse? Is it electrical? Is it chemical? Is it electronic? What is it? Remember we said that it was a specific, it had a specific nature to it. It's electrical, yeah. So because it's electrical, when they say within neurons, what they actually mean is within a single neuron. That is from the dendrite, so from one corner of that neuron to the other corner, which is the axon terminal. And because the message that's traveling within the neuron from one side to the other is always an electrical impulse or a message or a neural impulse, we say that it's electrical in nature, because another word for neural impulse is electrical impulse. Now, when we're talking about the other part of the question that says as well as chemical messages between neurons is no longer just one neuron involved, you've got two neurons involved. Yeah, when the message is being sent between neurons, it's being sent between a presynaptic sending neuron and a postsynaptic receiving neuron. Receiving neuron. Okay, and remember, guys, what's the name of the substance that our message or our electrical impulse or neural impulse piggybacks onto to get to the next neuron? Piggybacks onto to move across the synapse. Does anyone remember? It's the, yeah, NT, the neurotransmitter, correct. So that is what is involved. And we know, guys, what type of substance is the neurotransmitter? Electrical, chemical, electrochemical, electronic, what is it? It's a chemical substance. Yeah, so that's why this question makes you think a little bit more than you would want to. But yeah, sometimes you've got multiple choices like this that make you think a little bit more than you should have to for 1 mark. But that's, yeah, that's how it is. So nothing you don't already know, but just worded in a way that just seems a bit confusing there. Okay, that's why it's electrical messages within neurons, because within the neuron, the nature of the message is always electrical. It's a neural impulse, as well as chemical messages between neurons. Because when two neurons are communicating, remember, our message never travels alone by itself. It always piggybacks onto that neurotransmitter to move across the synapse. And that's why it says chemical messages between neurons. Does that make sense? Or should I explain it? Okay, cool. So I'll move on to the other question, which was 20. Oh, I need to get rid of this text box now. Okay, get rid of that and then move on to this question, question 13. Okay, so this is part of a research scenario. I'll just go up and quickly. Ravi conducted research to find out whether the coping strategy people used would affect their baseline levels of stress. 20 participants were exposed to simulations of 2 different stressful scenarios. In the morning, the participants were told to use avoidance strategy while exposed to the first simulation, and in the afternoon they were told to use an approach strategy while exposed to the second simulation. An electroencephalograph and electromyograph were used to measure levels of arousal. Before and during the simulations, higher levels of arousal indicated greater stress. Okay, readings from the EEG and EMG were quantified as stress level scores from 0 to 10. A change score was calculated by subtracting the pre-simulation stress level from the during simulation stress level. So basically, when they say pre-simulation there, what they're saying is the before they went through the simulation, that's the before score. And then during the simulation is after they've gone, is kind of after or while they're experiencing that stress. So we could say this is our after. It's kind of like pre-test, post-test kind of situation. So they've been exposed to 2 simulations or 2, I guess we can say, what's another word for simulation? 2 kind of trials or 2 kind of examples of different stressful scenarios. And then basically they've been told to use an avoidance strategy. So avoidance means not thinking about the stressor, but thinking about something else. And so in one condition, they were asked to use an avoidance strategy. In the other condition, they've been asked to use an approach coping strategy. Okay, so that's the scenario. So let's have a look at what the question is. So Ravi hypothesized that an avoidance strategy would be more likely to result in a bigger increase in levels of stress. Okay, which of the following supports Ravi's hypothesis? Right, so if we use an avoidance coping strategy, which one is more likely to occur? That's basically what he's trying to say. So in terms of the increase. So in this scenario, this is actually a really funny question. Hypothesize that an avoidance strategy would be more likely to result in a bigger increase. Okay, so we match up avoidance strategy here to here and basically just look for the biggest increase or biggest number. So what do we think, guys? What's going to be our best answer there?
6.2.
Yeah, it's going to be B. So that's the answer, because obviously he hypothesizes that the avoidance strategy is going to lead to a bigger increase in levels of stress. And so the mean change score for that reason has to be bigger in terms of quantity.
That's such a weird question.
Yeah, I know. It's kind of a silly
Like so
question.
irrelevant.
This question looks harder than it is, but it's actually not that hard if you just look at it. Again, another reason why VCAR need to rethink the way they write some of these multiple choices.
You should write them, not them.
No, I have better things to do. Okay. But does that make sense? Should I explain this a little bit more? Like, No stress, all good. If it said would result in a reduced or in a decrease or a decline, you would just choose the lowest number and just match up the keywords in the question to the keywords in the data. That's with these data questions, when they give you tables and graphs, it's not really, they're not going to ask you something that's going to be totally over your head. So don't overthink it. Just match up what you've got in the question to what you've got in the data there, and you should be all good there. Yeah. Alrighty, what other questions? I've got another one. Question 33 on, and have you marked my, yes, I have marked some of your papers that you've given me. I will email that back to you. Any hard copy stuff that you gave me, I will have to scan that through. I have a very old scanner that was probably created in the 1800s where you can only scan one paper at a time. So that will take me a little while, but I promise I will scan that through to you and give that to you probably over the weekend or on Monday. Okay, so anyone who handed me hard copy stuff to mark, those of you who have emailed me work to mark, I'll email that back to you most likely by tonight or maybe tomorrow night. Okay, so let's move on to the next question. So I will just quickly look into the chat box and see. Where's my Zoom gone? My Zoom is playing up today. I don't know why. Okay, where is it? Okay, here we go. Question 33 MCQ on Unit 3 exam. Which Unit 3 exam specifically? Is it like the Psych Ed one or? Okay, so the one that I just had opened up before. So I think I can just go back and just screen share that one again. Yeah, okay, this was the one. So question 33. Just scroll down. Okay, is this part of a scenario or just by itself? Question 12, it's a part of a scenario. Let's just quickly read through the scenario then. John decided to investigate the impact that stress has on memory recall. He thought that stress could be induced by, just make that a little bigger so everyone can see. Okay, he thought that stress could be induced by providing a shorter time limit to memorize words. In the first condition, the participants learned a list of 20 words presented on a piece of paper in 45 seconds. In the second condition, the participants had a different list of 20 words, but they only had 15 seconds to learn the words from the printed list before writing down as many as they could remember. He had informed the participants that the more words they could recall, the higher their pay would be to participate in the study. That's funny. Okay, the results are shown below. So in condition 1, they've been given 45 seconds to learn the list of 20 words, so more time. And in condition 2, they've been given less time. Okay, so they've been given the same, a different list of words, but the number of words they have to learn is the same. So it's still 20 words they have to learn, but only in 15 seconds. So you can imagine, obviously, if I gave you less time to learn the same number of words, you would recall less words. And that's what we see in the results here. Okay, so we can see here clearly that the condition 2 participants only recalled 7 on average, or a mean value of 7 words on average, compared to people in group 1 who recalled many more words, about 11.4 words, which shows a higher average, and this shows a lower average, which is kind of what you would expect if you were to redo this study in real life. Okay, so anyway, that's the basic idea. Sorry, that's the basic idea. Now let's go down and see the question. Question 13. Rather than stress causing the effect of the result in condition 2, yep, the one where there was lower words on average, a confounding variable could be. So now you have to look at what a confounding, remember guys, a confounding variable is just an unwanted variable. It's a variable that confounds the DV. So confounding variable we know is an unwanted variable, the other type of unwanted variable being extraneous. An unwanted variable or a confounding variable confounds the results or the DV by making it difficult to determine whether the IV, in this case, whether stress led to the change in results. In this case, the change in results is the number of words recalled, or whether it was some other factor. Okay, so now this question is asking us, let's consider that it was some other factor. From this list, which of the following factors could have acted as a confounding variable? Okay, that could have led to the change in results, that could have led to that low mean score of only 7 words being recalled. other than stress. So other than stress, stress is not the confounding variable. Stress is the specific IV that's being studied in this scenario. So think about it, have a look at this question and just think about what are the specific, what's a specific thing that we could think about without looking at the answer, but just try to, even if you're looking at the answer, try to think about why this would be the best answer there. And we'll, first of all, what we'll do is we'll cross out the options that are obviously not going to be correct. Okay, automatically we know that long-term memory has an unlimited capacity. Yeah, it's not a limited capacity. So automatically this cannot be the answer because long-term memory does not have a limited capacity. It's like a big cave. We can store so much information in it.
It has a relative permanent capacity.
Yes. Relatively permanent duration. Yeah, so that's correct. That relates to this one. So C, it doesn't have a limited duration. It has a relatively permanent duration. So that won't be thing. So already we've eliminated 2 answers there. A would be the limited duration of sensory memory, which wouldn't really make sense because sensory memory only holds information for 0.2 to 0.4 seconds. But these guys are being given how many seconds? I think one group was given 45 seconds and the other group was given 15 seconds. Yeah, if I'm not mistaken. So those were the 2 conditions. One group had 45 seconds to learn 20 words. The other group had 15 seconds to learn 20 words. If we look at sensory memory, the general duration of sensory memory is from 0.2 to about 4 seconds. Okay, 0.2 to 0.4 for iconic and 3 to 4 seconds for echoic. So if we combine those 2 into one duration, that's the general duration of thing. But both people in both groups had more than 0.2 to 4 seconds to learn. Okay, 45 seconds is way more than what the duration of sensory memory is, and 15 seconds is also more than the duration of sensory memory. So this is just irrelevant. It's not even related. So by process of elimination, the only remaining option is B. Okay, so that's the idea. The idea being that that would be another factor that could overtake the effect of stress to lead to the low average recall of words. Does that make sense or need further explanation? Oh, good. Okay, let me know if you need further explanation on that. Look, with multiple choice, sometimes just go through the options and just eliminate the ones that are definitely not possible. A lot of the time, that will allow you to narrow down to the options that actually are possible or that are plausible there. Okay, so same paper, question 33. Okay, let's move on to that one then. I'll just delete all the scribbles. Okay, is this related to a scenario 31 to 33? I'll quickly just read the scenario. Twin sisters Kirsty and Haley have just found out their mother has been diagnosed with Alzheimer's disease. Their sisters both handled the news very badly and worried about how they would be able to look after their mother. Okay, and then question 33. Alzheimer's disease is thought to be due to the death of brain cells caused by amyloid plaques, amyloid tangles, tau protein, tau plaque. So the answer is C. Yeah, look, with tau protein, it's not really, I don't know, it's not something that a lot of textbooks cover. I have seen it coming up in some exams. I've not yet seen it in a VCAR exam. But just to give you an idea, when we have these neurofibrillary tangles, the can't even pronounce the word, fibrillary tangles are accompanied by deposits of protein that are toxic to the brain, similar to amyloid, but basically the tau protein kind of forms a layer over the different neurofibrillary tangles. And so that tau protein, just like amyloid, is toxic to the brain and leads to the different cell deaths, also disrupting the neural communication and eventually kind of causing the destruction of those cells. So with reference to tau protein, you don't need to know a whole lot about it. You can probably just say that it's it accompanies the neurofibrillary tangles and that it's toxic to the brain. But other than that, you don't really need to know much about it. I mean, it's not even covered in most of the textbooks. I think Edrolo, I can't remember if Edrolo covered, I think it covered it in very little depth. But yeah, you can know that it's associated with neurofibrillary tangles. So you can remember that plaques have amyloid. That's the toxic substance for the plaques. The toxic substance for the tangles are the tau. Okay, that should be easy for you to remember because tau and tangles both start with the letter T or have the same first two letters. So yeah, if you do want to learn that and just make sure that you're covering all bases there, you can do that. Tau is not specifically in the study design, okay? But the way that VCAR are, you never really know what they're going to ask. So if you want to learn it, it's probably good to at least be familiar with this word rather than not know it at all. You can just think of tau as being the toxic protein that makes up the neurofibrillary tangles in the same way that amyloid is the toxic substance that makes up the plaques. Okay, so just remember it like that. Okay, any other questions from this paper, guys, from the Psych Ed Unit 3 while I have it open?
Miss, are you only discussing multiple choice?
Not necessarily. We can discuss the short answer too.
I was still in the chat box if we can do question 3 for 2019.
Oh, you meant the question 3 short answer. I thought you meant multiple choice. Okay, let me go to that then.
Okay.
I've got it already open here. Okay, let's have a look. Question 3. Okay, so question 3. So that's a scenario. So snake avoidance training saves dogs' lives. Veterinary surgeon Margie Gray is a strong advocate of training dogs to avoid snakes. Snake avoidance training saves dogs' lives. To prevent dogs from being bitten, she regularly engages an animal trainer specializing in reptiles to work with her clients and their dogs. The methods the trainer uses are described below. During the training session, the dogs wear a collar. That delivers a low-level electric shock sent by a remote transmitter held by the animal trainer. Over 2 or more sessions, each dog is exposed to a range of non-venomous snakes and trained to avoid these snakes. The animal trainer uses 2 different training methods in each session. The first training method involves conditioning the dogs to associate snakes with the electric shock delivered, and the second method involves giving the dogs a treat each time the dogs choose not to approach a snake. Dr. Gray said that even though the first part of the training uses an electric shock, she trained her own dogs using this method because she knows that treatment saves dogs' lives. So here in this scenario, you can clearly see that there's some kind of negative stimulus that's being associated with something that's usually neutral. Okay, in the same way that you might, develop a phobia by negatively associating clowns, which are usually a neutral stimulus, with something that's negative in nature, like the sight of a clown killing someone or the sight of a clown, throwing a sharp object at someone and causing them to bleed or something like that. So that could be, something we think about as we go into the question. So question 3A says, in terms of classical conditioning, describe how the animal trainer creates an association between the neutral stimulus and the unconditioned stimulus to develop a conditioned response. So this question is basically just it's worth 3 marks because it's basically you just describing what the specific, sorry, where's my text box here? It's basically you describing that 3-phase model of operant conditioning. You don't even have to talk about the 3 phases in a specific order there, but you will be drawing on your knowledge of what the 3-phase model involves in order for you to write your answer here. So the first thing you would want to mention here is that, your neutral stimulus is your snake. Okay, because remember, the reason that we want to teach dogs to be scared of snakes or teach dogs to avoid snakes is because dogs are not naturally scared of snakes, or dogs are not naturally aversive towards snakes. They're fine with the snake in the environment. But obviously, if they're fine with the snake in the environment, the snake can easily bite them and the dog can easily die. So that's why this treatment or this classical condition association is supposed to save the dog's lives. Okay, so you get a mark for talking about the snake as being the neutral stimulus. And you need to also talk about the fact that the unconditioned stimulus is the thing that would naturally cause some kind of fear or some kind of anxiety within the organism. So in this case, the negative, the unconditioned stimulus is going to be the electric shock. So if I just, oh my God, get rid of this text box. Undo. Okay, I need to scroll up. Oh, why can't I scroll up? Okay, I just want to scroll up so you guys can see the scenario as well. Okay, so when we're looking at this scenario, let me just delete everything and just start again. Okay, when we're looking at this scenario, we have to remember that the neutral stimulus is the snakes. This is the thing the dogs usually show no response to. Yeah, the UCS is the thing that the dogs will show a natural response to. In this case, it's important for the dogs to have some kind of fear. Okay, because in order for them to avoid snakes, the dogs need to be scared around snakes or need to show some kind of a negative response that would make them run away or avoid a snake. Okay, in this case, it's the electric shock from the collar. Electric shock from the collar. From the collar. Okay, so that's basically the NS and the UCS. So if you describe this part here, you automatically should be able to get 1 mark there, okay, just for stating it or just for describing it like that. Then you need to explain that there's a repeated association. Yeah, we can't just show the snake and give the dog 1 electric shock and expect the dog to be able to avoid snakes from there. That's not how classical conditioning works. Remember, one of the main components of classical conditioning is that there is a repeated association between an unconditioned stimulus and a stimulus that is originally neutral. So in this case, the dog will repeatedly be next to a snake, and then every time the dog is next to a snake, the trainer delivers that low-level electric shock. Doesn't kill the dog, but obviously shocks the dog into becoming quite startled and quite scared. Okay, so this is done repeatedly. Very similarly to how little Albert was not exposed to the white rat at 1 time and then the big drum was struck behind his head. It was multiple times. So striking the drum behind his head, that loud noise making him scared, showing the white rat. And that process continued. There was a repeated association. Otherwise, the organism is not going to make the link between the 2 events. Yeah, so you need to talk about that repeated association between the UCS and the NS with reference to this scenario. So using words like electric shock from collar, using maybe writing a sentence like there was a repeated association because the animal trainer continuously or repeatedly delivered the low-level electric shock every time the dog was exposed or was nearby to a snake. Okay, so that's the second mark. The third mark will basically come from you talking about the idea that the original neutral stimulus after the repeated association becomes a conditioned stimulus. Yeah, and now that this conditioned stimulus, now that the dog has learned to actually associate a response with the snake, the dog no longer shows like no response, the dog will actually show a conditioned response of something like maybe fear and running away due to the snake, or fear and avoidance, because that's what the scenario uses. They use the word avoid. Where did they use the word avoid? Yeah, here. So the conditioned response might be fear and avoidance of snakes. Fear and avoidance due to the sight of the snake. So every time the dog sees a snake, even if it's in the distance, it runs away or it avoids the snake. Okay, because it started to associate the negative kind of responses that it got from the electric shock, and it's associated this with this. Okay, so that's the basic idea. Does that make sense? We're not talking about operant here, we're talking about classical. So it says in terms of classical conditioning. So classical conditioning is our UCS, UCR, all that kind of stuff. So we are talking about classical conditioning in this scenario. Operant would have been us talking about like the antecedent, the behavior, the consequence, which isn't what, did I write operant before? Oh, that's weird. Okay, well, that's not what I meant. That should be my end of day brain then working. It should be classical. If I wrote operant, that was my bad. Yeah, so this is classical conditioning. Alrighty. So hopefully that makes sense. Look, guys, with this question, sometimes the questions VCAR gives you might not specifically ask you to use the 3-phase model, but depending on what the question is saying, most of the time that's what they would expect you to do, okay? In this case, it says, how does the animal trainer create that association between a neutral stimulus and an unconditioned stimulus and the CR? As soon as you see these 3 words, you know that you need to include that process. You know that you need to describe the process involved. All that scribble that I just put on the screen before was literally talking about what was the before conditioning, what was the during conditioning, and what was the after conditioning process. So if you follow that same structure for a question like this, there's no reason why you can't get the 3 marks, as long as you've linked it back to the scenario. Okay, and we've done a few questions like this as well earlier in the year. So just go back to your PowerPoint and your exercise book, because I remember we did do some of these 3-phase model questions in class as well. Is it a must that we have to put it in a sentence? Yes. So when you're just stating stuff like NS equals snakes, that's fine. That can be in a dot point. But when you're explaining that, okay, there has to be a repeated association between the unconditioned stimulus and the neutral stimulus in the beginning, example, blah, blah, that needs to be in a proper sentence. Yeah, because it is worth 3 marks. And we don't have the word list or identify in this question, which means that we're not really given an invitation here to use dot points. Okay, so for some parts of the question, like when you're first listing out the elements at the beginning, dot points are fine. But when you're doing the actual explanation of how the response was made, you need to use proper sentences there. Okay, if you look at this question here, let me get rid of the annotation thing first. If you look at this question here, this is how much space they gave you. You are also allowed to use the space at the bottom here. This is probably something I can point out. Okay, you are allowed to use up to here. Don't go beyond here. Don't write in this space. There's a reason they tell you that. Don't go too down the bottom as well. The reason is that generally they scan your exam papers. And when it comes to marking, we have to actually mark them on the scanned copy. I think they've been doing that for a few years now. So we don't get the actual physical copies of your exam anymore. They basically get the scanned copy. So if you've written something all the way down to the corner here, it might not get scanned or it might get cut off. Okay, don't even think about writing in this area. Don't even approach this black line, okay, on the side. Just be really careful. Stop around here or just stop within the actual bounds of the question. Teacher told me if we write over the line, examiners write over the line. What do you mean? Like in this area here, or you mean like over the line as in towards the side? So in this area? No, in this area, I don't know about other subjects, but for psychology, it's fine. Because when I went to that PD earlier in the year, I asked the a few of the teachers asked the chief examiner that same question. If you write in this area, before this bottom line here where it says section B question 3, this is fine. They will still look at that because the whole page gets scanned. But if you write really towards the bottom, like in this area or this area, it might not get scanned. So up to here is fine. If you want to add a few lines and continue your response up to this point, for example, then that is totally fine. That is not an issue. That will get scanned. Yeah. So that's all I can say for psychology. I have no idea about other subjects, but for psychology, we know that they scan the entire A4 paper. I'm not sure about other subjects. Maybe in other subjects, they only scan half the page or they scan it exactly where the question ends. I'm not sure. But for psychology, we know that they scan the whole paper. Okay, the whole A4 page. So you don't need to worry about that. Okay, next question. Did I miss any questions before? Let me see. Okay, unless I've missed any questions, let me just quickly check, guys. I don't want to have missed any questions. Okay, I think some of you had some content related questions which I wasn't able to explain because we went into some of the exam questions. So those of you who asked me for the content questions, like for example, the lock and key process, I'll explain that. But those are the rest of you, if you don't have any other questions, it's already 3:20. So yeah, you're free to leave. And if you have any other issues, you can always email me and I will be able to get back to you there. Okay, so what I'll do is I'll probably stop the recording here.